Hello everyone, today we will be solving the problem minimum cost for tickets. So this problem is all about we will be given three options. We will be given a 1 day pass, a 7 day pass and a 30-day pass, and we need to travel on the days that are given to us, and the cost of all the passes are given. Like cost of 0 will be the cost of 1 day pass, this is 2 day pass, and this is the cost of 7 day pass, and this is the cost of 30-day pass, and we need to travel on these specific days only. So uh, let's have a closer look on the problem. We can see that we have we have three options. What are all those options? Let's have a closer look. Okay, so the first option is buy 1 day pass, buy buy 1 day pass. And when you buy a 1 day pass, you will need to perform, like suppose this is the array that you have been given. Okay, so let us assume that you are standing at this index. Let us assume that you are standing at this index, and at this index you buy a 1 day pass. So if this is suppose 3 and this is 7, so when you buy 1 day pass, you will be able to travel just 1 day. Okay, that's fine enough. Yes, so after traveling 1 day, what you will need to do is you will need to move 1 day ahead. So you will come at 4, but at 4 you do not need to travel. So actually after 3 you will move to 7. So my solve function, this is my solve function, and solve function will be called for I plus 1. So this is the first option that we are having. What is the second option that we have? The second option that we have is you can buy a 7 day pass, and when you buy a 7 day pass, you will be able to travel 7 days, right, without any money. So suppose this is 3, this is 7, this is suppose this is okay 15. Cool. So when you buy a 7 day pass from here, the cost will be the cost of that 7 day pass, plus you will have to solve for what index? You will have to solve for this index. You know why? Because 3 plus 7 is at max you can go 10, and after 10 you will need to bypass. So you will need to search from this index, right? So suppose the index is j, so you will have to search from j. And again, at third option you will be having is you buy a 30-day pass. And when you buy a 30-day pass, suppose one more index is given over here, and you have suppose you have 45. So what you need to do, can you travel with a 30-day pass till 45? No, because the max that you can travel using a 30-day pass is 33, and after 33 you have 45. So you need to buy a pass now here. So you will need to have solve for this problem. Okay, so from this problem to this problem you will need to solve. So suppose the index is k over here, so you will need to solve for kth index. Now all these options are now done. Now what we need to do, since we what we require, we need minimum of all these three options. So what you will need to do, suppose this is c1, this is c2, and this is c3. So my minimum, what it will return is, my function will basically return c1 comma c2 comma c3. Okay, so let us have a look at time complexity. So whenever we are standing at an index I, we have three options, right? We have three options: either by 1 day pass, either by 7 day pass, or by a 30-day pass. So when you have three options at each and every index, the time complexity will be 3 की power n, 3 power n. So let's have a look at n. So it is 365, right? So the time complexity in the worst case will be 365. So don't you think that this will give a TLE? Yes, 3 की power 365 will give us TLE. So we need to optimize this problem. So you see, this is a recursion problem, and a recursion problem can be optimized by dynamic programming. So what we do in dynamic programming, well, we just store the states. Like if I am at this state, I'll store the value that had come at this stage. Cool. Okay. So now we need to determine how many state DP this will be. Either it will be one state DP or two state DP. We need to, how can we determine that it is a one state or two state DP? We will need to check how many variables are changing at each stage. The only variable that is changing at each stage is I, that is index of the variable. So you need to create a DP of 365. Why 365? Because it had been given that we have 365 days for traveling. So we made a DP of 365 and stored -1 in each, right? And after that, what we need to do, we just need to return this, we just need incorporate this DP of index is equals to minimum of C2 C2. This only, this is the change that we have in. So now let's revise this whole concept what we actually did. So at, suppose I am standing at ith index, I will be having three options. Cool. I will be having three options. One of the option is I will move to I plus 1, one of the option is I will move to j, and one of the option is I will move to k. So I plus 1 is the option when we buy cost of 0, and this is the option that we buy cost of 1, that is a cost of 7-day ticket, and here cost of 7-day ticket, right? And again you will be having three option here, again you will be having three option here, again you will be having three option here. So this is whole recursion tree, pseudo recursion tree, I would say pseudo recursion tree. Okay, so simple. Now let's have a look at the code and see what is the code saying to us. Okay, so you see, this is the solve function. This is, we have initialized dp over here and initialized dp with -1, and we have returned, this is the index. We have started with 0th index. So in case my index exceeds my number of days size, we will need to return 0 because we cannot buy anything. So this is basically the base case. This is basically the base case, and this is the main memoization that we are doing. So see, now we have three options. So option one is to buy 1-day ticket. So when you buy 1-day ticket, you will add the cost of that 1-day ticket and you will call recursion for the next index, right? So now the second option that we have is we can buy a 7-day ticket. Now how do we buy a 7-day ticket? Now think of it, how do you buy a 7-day ticket? That's, I guess, very simple. I mean, you have to take the cost of, you have to take the, see here, you see here, okay, see here, you will have to take the cost of the 7-day ticket and you will need to pass on the next index where we need to solve. So for this index, the next index, I have used this for loop. This till my days of I is less than days of index plus 7, I will keep on moving, and my I will point to the next jth index that we discussed in our approach while we discuss the approach. So this is the option 2. In the similar fashion, this is the option 3, and in we need to take the minimum of all these three options. So this is the minimum. Had we not used recursion, we would simply return mn, and one thing that we need to remove is this stuff. Okay, memoization we need to remove, and we just simply return minimum, and this is just recursion code, right? This is just recursion code, but since, see, this test case is accepted, I guess it will give TLE because it is the time complexity 3 ki power. Okay, see, the time complexity is very large. TLE has arrived. So what we need to do, we need to incorporate recursion, sorry, no, dynamic programming. So okay, so this, we have memoized the solution, and after memoizing the solution, we just need to uh, return this state dp. Okay, so dp of index is equals to mn. Now we will run. I hope this will run fine. Okay, now submit it. Okay, that is an accepted solution. Thank you for watching. Subscribe for more such videos.